Hello everyone. Today I am going to discuss McCabe's cyclomatic complexity with an example. What is cyclomatic complexity and how to find the cyclomatic complexity? I have already discussed on this thing in my previous videos. If you want to watch those videos, you can subscribe the channel and watch the videos on white box testing as well as the cyclomatic complexity. Okay, now in this tutorial I'm going to discuss one problem, that is find the cyclomatic complexity from the following program segment. Okay, here void abc int a equals to 5, b equals to 10, c equals to 15, int I equals to 0 for I equals to 0, I less than 5, I plus plus, a plus plus, b plus plus, printf a b, and while b less than c, there is if a greater than b, printf a, else printf b, b plus plus, and then printf c is there. Okay, so we have to find out the cyclomatic complexity for this program segment. Okay, uh, now the first to find the cyclomatic complexity, there are some steps. First, we have to give the number to all the statements. That is, all the statement of the program must be number first. Okay, that is number one. Then the different number statement will be served as the nodes of CFG. Okay, so here by this numbers we'll draw a CFG, and by the CFG we have to find the cyclomatic complexity. Okay, now after numbering, how it will look, just see how to before that just check how to give the numbers. Here this first line will be number 1, after that int I it will be number 2, then for I equals to 0, I less than 5, I plus plus, number 5, then 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, uh, 17 and so on, 17, 18. Okay, so these are the numbering. Okay, and after numbering, just see, this will be like this. Okay, see, you can omit these braces. Okay, it will not affect in your cyclomatic complexity, like number 14, number 14, number 16. Okay, they can be omitted, and 13, 14, they can be treated as a same node. Okay, or same number. It will not affect the program. Similarly, 15 and 16 both can be treated as only one node, then also there will not be any problem. Okay, now according to this numbering, we can see that there are 16 number of statements. Okay, so we'll have 16 nodes in our CFG. How to draw the CFG, let's check first. Okay, so starting from the beginning, that is from number 1. Okay, from number 1, how the program counter will be going on. See, it's a sequential statement, so from number 1 it will directly go to number 2. Okay, and these are the edges are edges from one node to another node exist if the execution of the statement representing the first node can result in the transfer of control to the other node. That means the edge will exist between two nodes if there is a connection from the first node to the second node. Okay, now here node number 1 to node number 2, see, there is a connection, because from node number 1 program counter will pass to program node number 2, and after that 2 to 3, right? Here 2 to 3, so from 1 to 2, 1 to 2 there is an edge, after that 2 to 3 there is another edge. Okay, now it is a for loop at 3, and 4 and 5, this is the body of the loop. 4 and 5, this is the body of the for loop. Okay, so 3 to 4, 4 to 5, it is there is no problem. Now see, from 5 it will again go to number 3. Why? Because it is a loop. Okay, so at the beginning I equals to 0, then 0 is less than 5, so a plus plus b plus plus, again here it will be I plus plus, so I will become 1. Then again it will check I whether 1 is less than 5, yes, so again 4 and 5. So by this way the loop will be continued. Okay, now where the loop will end, is it end at 5 or is it end at 3? See, as we know, for loop is an entry control loop. Condition is checked at the beginning, so it will be end at number 3. Okay, so after getting the body at the whenever it will check first that whether the value of I is less than 5 or not. If it is not satisfied, that means if it is false, then directly it will go from 3 to 6, that is the end of the loop. Okay, so 3 to 6 there will be a connection, and after that 6 to 7, see, printf and then while, so 6 to 7 there will be another thing, another node. Okay, it will be in sequence. So now after that, after 7, if we want to proceed 7, there is a while loop. Okay, so at 8 the body of the while loop is started, then 9, then 10, 11, 12, okay, 13 and 14. At 14 body of the loop is reaching the end of the loop. Okay, so here from 8 to 9 there is a sequence, so there is no problem from 8 to 9. After that at 9, see, there is a if statement here. If statement means branching, so one if statement and along with that one else statement, right? So from if a greater than b it is satisfied, then 9 to 10 there will be a path, 9 to 10 there will be a path. You can see here 9 to 10 there is a path. Okay, see, print at 10 it is printf. So after that, after printing a, from 10 it will directly go to the number 13, right? And if at 9 here a greater than b it is no, it is false, then from 9 it will directly go to number 11, that is else, and from else, that is 11, so 9 to 11, right? After 11 it will be 12, so 11 to 12, and from 12 again it will go to 13. So there are two parts. Okay, from 9, 10, 13, and another one is 9, 11, 12, 13, right? And after 13 it will go to the end of the loop, that is number 14. Now again here while it is the while loop, and while loop is entry control loop. See, condition is checked at the beginning, b less than c. Okay, here b less than c, so it is also entry control loop, so the loop will be terminated at number 7. Okay, so from 7 to 15 it will directly go to 15. So 7 to 15 there is a path. Okay, after that 15 to 16, so 15 to 16, so this is the cfg for the program segment. Okay, now in this cfg we can see there are 16 nodes. Okay, now how to draw the how to find the cyclomatic complexity using that cfg, that is our step number 3. There are 3 methods for finding out the McCabe's cyclomatic complexity. First of all, we will check the method 1. So in what method 1 says, cyclomatic complexity Vg equals to e minus n plus 2p, where e equals to number of edges, n equals to number of nodes, and p equals to number of connected components. Okay, now what is the number of nodes, that is n, you can easily see there are 16 number of nodes. Okay, after that, what is the number of edges? You can easily count. uh, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 and 18. Okay, so 18 number of edges are there. So 18 and 16 we have already got E and N. And now what is P? P is the number of connected components. So connected component means, what is connected component? Suppose there is a graph. Here these four are connected. Okay, there is another graph, they are also connected. Now consider these as a whole graph. So here, see, from see, it is 1 2 3 4 and 5 6. Okay, 5 6 there is a connection. 1 4 2 4 3, there is a connection between any two edges of this, of the left part, left side. Okay, and right side also, and there is a path exist from 5 to 6 and also from 6 to 5. Okay, but we cannot find any path from 1 to 6 or 2 to 5. There is left part to right part or right part to left part. Okay, so these two parts are separated from each other, although these two parts are the subset of the whole graph. Okay, so here we can see there are two different connected components. One is 1 2 3 4, another is 5 6. Okay, but here in this graph, in our graph, it is, see, only one connected component is there, because you can find at least one path between any two nodes. Any two nodes there is a connection. Okay, do not consider the directions of the edges, just consider whether there is a connection or not. Okay, so just check 1 to 16 there is a connection, 1 to 11 there is a connection, 10 to 5 there is also a connection. Okay, so by this way you can find that number of connected component in this graph is 2. Sorry, number of connected component in this graph is 1, right? So it is 18 minus 16, that is E minus N, plus 2 into P, the value of P is 1. Okay, so it is equals to 2 plus 2, that is 4, right? Sorry. So by method 1 we are getting the cyclomatic complexity Vg equals to 4. Now what next? The next method says Vg equals to cyclomatic complexity Vg equals to number of bounded areas plus 1. What is bounded areas? That is closed region. Here you can see 3 4 5. It is a closed region. Okay, so 3 4 5, it is a closed region. Now we cannot consider 3 4 5 6, because from 5 to 6, see, there is a gap, so it is not considered as closed region. Again 9 10 11 12, sorry, 9 10 13 12 and 11, this is a closed region. So two closed region we have already found. After that 7 8 9 11 12 13 14 7, it is another closed region. So how many closed region we are getting? We are getting 3 closed region in this CFG, okay, or controlled flow graph. So it is 3 plus 1, that is the cyclomatic complexity will be 4. So by these two method we are getting cyclomatic complexity as 4. Next method is method 3, that is Vg, the cyclomatic complexity equals to number of predicate nodes plus 1. Now what is predicate node? Predicate node means which nodes that contains the decision statements. What is decision statement? It's a trick that you should remember. The decision statement means the nodes which will have conditions, those will be considered at sorry, those will be considered as uh, predicate nodes. And we have to find how many nodes of that types are there in the CFG. Okay, so here, for finding out this, just check in this program how many conditions are there. See, node number 3, that is for loop I less than 5, it's a condition. After that, node number 7, while loop, there is a condition, and node number 9 also has a condition. Okay, so we are getting 3 conditions in this program segment. Another trick is there how to find out the predicate nodes is just check the nodes from the without considering the program. You can find out the predicate nodes also. Okay, just consider the nodes which have branches, that is more than a node which contains more than one branch, that will be treated as a predicate node. See, number 3 has two branches, 3 to 4 and 3 to 6. So this one and this one. So 3 will be considered as one of the predicate node. After that, from 7 to 8 and 7 to 15. So 7 is another node which is considered as predicate node. Again, from 9 to 10 and 9 to 11, two branches are coming out. So 9 will be also considered as predicate node. So we are getting 3 predicate node here in this CFG. So it is 3 plus 1, it is equals to 4. Okay, so considering as a whole, we are getting by all 3 methods the cyclomatic complexity is 4, which is same. Okay, now remember, if you will not find the same value for the cyclomatic complexity by all these 3 methods, then there might be some problem in your solution. So then in that case, check the solution once again. Okay, so that is all about the cyclomatic complexity for a given program. Okay, and how to find out, I hope you have understood. uh, if you want detailed discussion regarding this, you can check the other videos on the same topic, uh, which is available in my channel. So just subscribe and watch those things. Okay, so and for new videos, don't forget to click on the bell icon. Thank you for watching.